The U.S. Air Force Nuclear Weapons Center has awarded Boeing a $49.5 million sole source contract to modernize key electronic components supporting the AGM-86B Air-Launched Cruise Missile, ALCM, ensuring the continued operational readiness of one of the United States' cornerstone airborne nuclear deterrent weapons. Announced on June 30th, the agreement covers the remanufacture of the missile's electronic flight controllers, as well as the production of specialized test equipment required to certify the upgraded units. Although the overall program spans 7 years, the Air Force has initially obligated nearly $3 million from its fiscal year 2026 missile procurement budget to begin the effort. Because Boeing designed and manufactures the AGM-86B, the work was awarded without competition, with the company recognized as the only source capable of performing the required engineering and sustainment activities. The modernization effort will be carried out at Boeing facilities in Heath, Ohio, and Fort Walton Beach, Florida. In this video, Defense Updates analyzes why 4-decade-old AGM-86B will continue as air-launched leg of U.S. nuclear triad till 2033. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The AGM-86 is a family of subsonic air-launched cruise missiles developed by Boeing to give the Boeing B-52 Stratofortress the ability to engage heavily defended targets from well outside enemy air defense envelopes. By allowing the bomber to strike from long distances, the missile reduces the aircraft's exposure to hostile defenses while forcing an adversary to detect, track, and counter multiple incoming threats simultaneously, thereby increasing the complexity of its air defense operations. The missile reached operational status in 1982. Every AGM-86 variant is powered by a Williams F-107 turbofan engine, enabling sustained subsonic flight over long distances. After release from the launch aircraft, the missile automatically unfolds its wings and tail surfaces while opening its engine intake before transitioning to powered flight. It can be launched from either high or low altitudes, providing mission planners with considerable operational flexibility. The AGM-86B, the nuclear-armed version of the missile, has a range exceeding 1,500 miles, 2,400 kilometers. It carries a W-80 thermonuclear warhead with a selectable explosive yield, ranging from 5 to 150 kilotons, allowing it to be tailored for different target sets. To accurately reach its objective, the missile relies on a terrain contour matching TERCOM navigation system, which compares measured terrain profiles with stored digital maps to maintain a precise flight path while remaining at very low altitude. The contract awarded to Boeing focuses on one of the missile's most critical electronic assemblies, the controller, which serves as the central processing unit for the weapon throughout its mission. This component coordinates flight control inputs, engine management, onboard navigation, and the terminal guidance sequence from launch until target impact. Sustaining a weapon introduced more than 4 decades ago presents challenges that extend far beyond routine maintenance. Many of the original electronic components used in the AGM-86 controller are no longer manufactured, making direct replacement impossible. As a result, Boeing must redesign and rebuild circuit boards and electronic assemblies using modern components that replicate the performance and functionality of obsolete hardware while remaining fully compatible with the missile's existing architecture. The contract also includes production of dedicated test equipment designed to validate every remanufactured controller. These specialized test systems ensure each rebuilt unit performs exactly to the original military specifications before it is certified and returned to the operational missile inventory. First fielded in 1955, the B-52 subsonic strategic bomber is the lone platform certified to deploy the AGM-86B weapon system. The active fleet consists entirely of the B-52H variant, which features a maximum capacity of 20 of these missiles, distributed across both internal and external carriage systems. The bomber is being upgraded to remain operational till 2050, and the designation of the new variant is B-52J. The aircraft is scheduled to have its Pratt & Whitney TF-33 engines swapped out with brand-new Rolls-Royce F-130 engines. The modernization initiative for the bomber is referred to as the Commercial Engine Replacement Program, CERP. As part of the CERP effort, a new Collins Aerospace electric power generation system will be implemented, offering a remarkable 30% improvement in fuel efficiency. Further, through the radar modernization program, the outdated APQ-166 radar, which received its last modernization in the 1980s, is set to be replaced with a new radar system known as the APG-79 Bomber Modernized Radar System, an active electronically scanned array, AESA. It is based on APG-79, developed for the U.S. Navy's FA-18 Super Hornet fighter and EA-18G Growler electronic warfare aircraft, and will greatly improve situational awareness and air-to-air and air-to-surface capability. The cockpit of the B-52 will undergo a transformation, adopting streamlined appearance with new color displays with a modern glass cockpit design. Other planned additions include Link 16, a communication system that will allow the B-52J to network with a broad range of other U.S. and allied aircraft and exchange their tactical picture in near real time. The AGM-86B's eventual successor will be the Long-Range Standoff, LRSO, cruise missile, a next-generation nuclear weapon being developed by Raytheon Missiles and Defense under contracts first awarded in 2017. Designed to deliver greater survivability, enhanced stealth characteristics, and significantly improved range, the LRSO will equip both the B-52 and the Northrop Grumman B-21 Raider, ensuring the airborne leg of the U.S. nuclear triad remains viable against increasingly sophisticated air defense networks. The LRSO program entered the engineering and manufacturing development phase after achieving Milestone B approval in 2023. However, fielding the missile remains a multi-year effort. Initial operational capability is not anticipated until the latter part of the decade, while the complete retirement of the AGM-86B fleet is expected to extend well into the 2030s as production ramps up and the new missile gradually replaces its predecessor across the bomber force. Boeing's sustainment contract, which runs through 2033, is therefore strategically timed to bridge this capability gap by keeping the existing cruise missile reliable, fully certified, and mission-ready until the LRSO is available in sufficient numbers. The decision to continue investing in the AGM-86B also reflects the unique realities of maintaining nuclear weapons. Unlike conventional munitions, replacing a nuclear delivery system is an exceptionally lengthy and expensive undertaking. Every new weapon must undergo rigorous engineering validation, extensive testing, and stringent certification to guarantee both operational effectiveness and absolute safety. Even seemingly modest design changes require exhaustive analysis to demonstrate they will not affect weapon reliability, security, or performance under normal and abnormal operating conditions. Against that backdrop, refurbishing critical subsystems, such as the missile's electronic flight controller, represents a practical and economical solution. While redesigning obsolete electronics demands significant engineering effort, extending the service life of proven hardware is substantially less expensive and far less risky than accelerating the deployment of an entirely new nuclear cruise missile before it has completed development, testing, and certification.